Hello guys, my name is Mohammad Murtaza, and in this video we will be discussing about Young's double slit experiment. It is totally based upon interference of light. Might be it will be constructive interference or it will be destructive interference. So if you haven't subscribed to my channel yet, so please subscribe to my channel and also press the bell icon so that you will receive more of my videos. Also, if you like my videos, so comment below and tap the like button, and you may share so that I can get popularity more. So let's get started. Before starting the Young's double slit experiment, I shall I shall see you a video. I will provide you a video. You will have to watch it, and then we will go straight into Young's double slit experiment. If you haven't watched my interference of light video, then it's a link in description below. You can click it. You will get to watch my video. Or if you have cleared concepts of interference of light, then you can easily understand what I'm gonna tell you about Young's double slit experiment. Basically, there uh, after interference have been known, Thomas Young, a scientist, there is a scientist called Thomas Young, performed an experiment using double slit, means two slits. Now what are slits? Basically, for example, let's take this is a cardboard, and let's suppose I just take a cutter and cut this portion of cardboard, this portion, and in very little distance I just cut another portion. Now these two are called small openings, and these two are basically known as slits. You can call them small opening, but basically we're gonna call it as slit. So Thomas Young performed an experiment using double slit and a monochromatic light, and using it he developed interference of light. He performed the experiment of interference of light and observed bright and dark fringes. So let's get straight into the video.
And here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands. Good so far.
Alright, in the video you have already seen about waves. So in the video you have basically seen two types of interferences. Okay, let's get straight into the topic. In the first, you say when he was throwing marble particles through single slit or double slit, basically there was no interference pattern observed. Why? Because they were particles. As you can see, it's physically normal, you can understand. But when he took waves and launched between the double slit, then what happens? There was a, you can say, a visual screen where you obtained bright and dark fringes, just like this. If, for example, this is bright, for example, this is bright and this is dark, just like that, bright, dark, and then bright, and then dark, and then bright, and then dark. This type of fringes you basically watch. What happens is that when two waves are passed through two slits, they are allowed to interfere, and when they interfere, they produce interference of light. Now there will be two conditions for interference of light. Number one is constructive, and number two is this destructive interference. And because of this interference of light, they obtain bright fringes and dark fringes. Now, before going into the experiment, how this experiment is performed, what are the equations to solve this experiment, I'm gonna tell you something that when interference becomes constructive, a bright fringe is obtained, and when interference becomes destructive, then dark fringes are obtained. Dark basically are very dark because the two lights are gonna cancel each other, no light is produced, so it will be dark there. And when two lights are gonna interfere, they have a greater intensity, then it will be very bright. So you can see. Alright, let's get straight into the experiment. Alright, now here what he did is that he take a monochromatic light as a source. He took monochromatic light as a source, and then what he did is that he placed a glass in front of a monochromatic light and made a single slit in between it. Now the light is allowed to pass through this single slit, and now what happens is that basically he placed another glass, and another glass contains not single but double slits at equal distance. So right, these are double slits and this is a single slit, so monochromatic light is allowed to pass through a single slit, and then the monochromatic light is allowed to pass through another glass having double slits. And now what will happen is that when let's make a diagram first. They're gonna diffract like this, and what will happen is that like this, and now these lights are gonna pass through both of the slits, and what will happen is that, as you can see in the video, the waves were bouncing all over the visual screen, but if we want to make a diagram, so if we cannot show every kind of fringe, that this is bright, this is a dark, this is a bright, this is a bright, you will understand me later. And then these lights are now gonna hit the visual screen. This is a visual screen, and there are now gonna two light rays are now gonna interfere and will produce either constructive interference or either destructive interference. So this is ray 1, this is ray 2, and for example, the distance between two slits, I can name it as D. Let's assume this point as origin, and this is angle 90 degree, and this is assumed as P point. Alright, what happened is that only not these two light are gonna interfere, there are number of millions of light waves are gonna interfere all over the visual screen. But basically, in order to calculate and make equations and derive equations, we just have to consider a single point P on a visual screen, which is at y height above origin. Now this is the distance between O and B, y. Alright, now the distance between two slits is D, and distance between slit and screen is L. Alright, the slit and screen is exactly equal to D and O, so I can call it as L. Alright, now let's make a dotted lines here, connecting to P. Alright, now let's name the points. For example, this is point A, this is point B, this is point P, and this is point Q, and the distance between two slits is D. So I hope you will understand what I'm gonna say. The distance between slit and screen is L, but these distances are almost equal to Q and O. So I'm gonna name it as this. Alright. As you can see, the ray 2 is covering much more distance than the ray 1. How much distance is the ray 2 covering much more than the ray 1? You will draw a perpendicular from the terminal point A over the ray 2. Now as you can see, after I draw a terminal, now this is the distance much more covered by ray 2 than ray 1. So now as you can see, ray 1 and ray 2 are equal, and they're gonna interfere due to superposition principle, and then it will be constructive interference or either it will be destructive interference at point P. So either it will be a bright fringe, either it will be a dark fringe. Alright, as you can see, when we were discussing about interference of light, so we rely on path difference. When path difference was m lambda, then interference was constructive, and when path difference was m plus half lambda, then interference was destructive. But what is path difference? The much more distance covered by any ray than other ray. As you can see, R2 is covering this much more distance than the ray 1. So this is called path difference. So basically we are going to denote it as S, but S stands for path difference here. Alright. Assume this Q as angle theta. This is Q. Angle Q, I'm gonna write it here. And this is angle A. It is very small, but you have to do it. Alright. These two angles are same. Because you haven't performed experiment, so you don't know about it. I also haven't, but these two angles will be same. Alright. This is path difference S. And let's call this name as C. This is a triangle ABC. This is angle 90 degrees. So congested, I know, but it's easy if you just perform this experiment. So this is the whole experiment that we will be talking about Young's double slit experiment. And Thomas Young performed this experiment to observe interference fringes and observe wavelength of light. Alright, let's develop some equations relating to Young's double slit experiment. Alright. This is triangle ABC. I can just draw like this here. You can see this is basically the triangle ABC, which is here, in which this is path difference S denoted. This is distance between two slits, you call it D, and this is nothing, just it's nothing. Alright, this is angle theta. I'm gonna mention it as black. This is angle theta. The side in front of angle theta is opposite, and the side in front of 90 degree is called hypotenuse. So the ratio of opposite over hypotenuse is basically sine theta, which we can say sine theta is equals to opposite over hypotenuse. And opposite is S and hypotenuse is D. So this is equation 1. Alright. Now another equation, let's see. This is triangle QOP. So we're gonna now develop an equation using triangle QOP. Okay. In this triangle, as you can see, angle Q is theta. This is opposite side because it is opposite to theta. This is adjacent, and the ratio of opposite over adjacent is basically tangent theta. So tangent theta is equals to opposite over adjacent. Opposite over adjacent is tangent theta. As you can see, this is opposite y, and this is adjacent, so this is L. So y over L is tangent theta. We get equation number 2. So we have developed two equations. Number one is tangent theta and other one is sine theta. I think I should remove this as S over D, equation 1, now looking better, and this is y over L, now it's much better. So equation 2, so we get developed two equations. Alright, these interference fringes, let's how to compare. You haven't performed this experiment by using your own hands, by using your own eyes. But when you perform this experiment, basically these interference fringes will be produced at 1 millimeter height, 2 millimeter height, 2.5 millimeter, might be 0.5 millimeter height above origin. So as you can see, these interference fringes are much smaller. The gap between my fingers are just 0.5 millimeter, 1 millimeter, 2 millimeter. As you can see, this is looking much bigger. I just draw this diagram. It's just looking much more bigger. The angle is looking like it's up to 30 degree, 45 degree, 60 degree, but it's not in reality. In reality, basically, interference fringes are at 1 millimeter height, 2 millimeter height, and so small that the angle also becomes small due to these small interference fringes. And when angle becomes small, so small, then there is a property we will apply. When theta angle becomes less than 10 degree, usually at these heights it is it is in reality that angle is less than 10 degree, and when angle is less than 10 degree, then sine theta at any from sine 1 degree to sine 9 degree is approximately equal to tangent theta from the tangent 1 degree to tangent 9 degree. This is very good concept, because if you for example you take the value of sine 9 degree and you take the value of tangent 9 degree, so basically they're not equally equal, but I mean they're not totally equal, but they're approximately equal. If you take the value of sine 5 degree and tangent 5 degree, they are not totally equal, but they are almost equal. So basically they are approximately equal. You will try in the calculator. I'm just giving you some tasks you have to perform by yourself. So when the angle becomes small or less than 10 degree, then sine theta is approximately equal to tangent theta. So I can write instead of tangent theta, sine theta. So there we go, sine theta is equals to y over L. This is equation 2, same equation 2. Alright, these two equations we have constructed. One is equation 1 and this is equation 2. Both left hand sides of the equation are same, so we can compare them and we can write a single equation. S over D is equals to y upon L. I need to find the value of y, so let's get L into left hand side. So L over D into S is equals to y. So this is equation we have generated from Young's double slit experiment. And now what we have to do much more. Alright, this S is basically, you can see, path difference. And when path difference, if you have seen my video or if your concepts of constructive interference are clear, then you can say that when path difference becomes m lambda, when path difference is, this is PD stand for path difference, is m lambda, then interference is constructive. And when path difference is m plus half into lambda, then interference is destructive. If you haven't watched my video yet, you have to watch my video. It's in the link below description, so you can see it. So when path difference is m lambda, a bright fringe will obtain, and when path difference is m plus half lambda, then dark fringe will obtain. So path difference is xs. So if I put m lambda instead of s, we will obtain a bright fringe, and when I put m plus half into lambda instead of s, we will obtain dark fringe. So let's put these values. So y is equals to, let's put m lambda instead of s, L upon D dot m lambda. This is equation for bright fringe, or you can say bright fringes. Alright, And this, when we put m plus half lambda instead of s, then there we go, L over D m plus half into lambda. So this equation is for dark fringe or dark fringes. Alright, so we have developed two equations using interference of light using Young's double slit experiment, and we can observe wavelength of light. This is wavelength we can observe because we can know the value of m. We know the distance between two slit and screen. We know the distance between two slits. We know the heights of fringes. So what is remaining, lambda, we can easily calculate the wavelength of light. So that is why Young's double slit is very helpful for calculating the wavelength of light. Alright, let's go to another topic. Using this, we can obtain a lot more. Alright, when for bright fringes, I'm just talking about bright fringes, when m is equals to 0, when we put 0 instead of m, then this whole factor will be 0, so y is equals to 0. Or when m is equals to 1, then we put 1 instead of m and we obtain y is equals to L over D dot lambda, or you may write it as lambda L over D. Any way you can write. So these are okay. Now let's try another. Just a moment, I'm gonna talk over. Alright. Alright, now for dark fringes, when m is equals to 0, if you put 0 instead of m, then what will happen? Y is equals to 0 plus half is half. It will develop this equation lambda L divided by 2D. When m is equals to 2, alright, since m is equals to 0, when m is equals to 1, but if you put 1 instead of m, then 1 plus half is basically 3 by 2. So L over D into 3 by 2 lambda. And when 3 into L into lambda is equals to 3 lambda L divided by 2D. So this is when m is equals to 1. And now let's talk about the distance between two consecutive bright fringes and distance between two consecutive dark fringes. Basically the distance, alright, let's suppose this first bright fringe is obtained at y height is equals to 0. How? Because when m is equals to 0, then y is equals to 0. It means a first bright fringe which will obtain here, and first dark fringe will obtain here. Let me make this visible for you more. This is first bright fringe, this is first dark fringe. Just not like this, like circular, but you can, in the video, as you can see, it's almost completely like in the video. Then bright fringe and then dark fringe, like this. It's continuing up to upward, so the distance, we are now calculating the distance between two bright fringes and the distance between two dark fringes. Alright, basically the distance between two bright or two dark fringes is called fringe spacing. Just remember these equations, this one, this one, this one, and this one. So just remember these. Alright. Now what will happen? This is first bright fringe when y is equal to 0, and this is second bright fringe when y is equal to lambda L upon D. So if I say what is the distance between them, so I just subtract 0 from lambda L over D. So y delta means delta represents the sign of distance between two bright fringes. Lambda L, here's the lambda L, so we're gonna write lambda L over D minus 0, first bright fringe, is equals to lambda L over D. So this is fringe spacing. Alright, this is the same distance for dark fringe. How to prove? Let's prove it. This is first dark fringe, this is second dark fringe, and the distance between two dark fringes is del y is equals to 3 lambda L divided by 2D minus lambda L divided by 2D. Alright, The denominators of both factors are same, so we can add or subtract easily. 3 lambda L minus 1 lambda, if basically there is 1 when nothing is here. 3 minus 1 is 2. 2 lambda L and denominator is same. So cancellation of 2, where here we get lambda L upon D. As you can see, the fringe spacing is same. So fringe spacing for dark and for bright fringes are same. So the fringe spacing is basically the distance between two consecutive bright or two consecutive dark fringes. And how much is the distance? This is the distance between two consecutive bright or two consecutive dark. Hopefully you like my video. If you like my video, then please subscribe to my channel if you're new here. And if you already have subscribed to my channel, then please comment to my section and and also you can share my video. And whoever is new here, I already told you to subscribe, but don't forget to press the bell icon so that you can get more videos from my channel. Okay, let's get a laugh.